So it's recording. The slide and demo code will be uploaded into this tiny URL. So uh, you should be able to go there, grab everything, even from the previous meetings, everything is there. These are some of the future sessions. As you can see, um, the lineup, there are some speakers from Microsoft, some around the world. In April, we are planning to bring a bunch of PMs that you can ask any question, mostly on the SQL Server, managed instance, Azure SQL, in those area. We also have a couple of other Microsoft employees who will be coming and talking to this group. If any of you want to speak or you have a speaker in mind, do drop us a line in this email address. Future events other than our group, I listed those here. There are SQL Saturdays, Data Saturdays, SQL Beats, Data Minutes is coming, um, um, which is pretty fun. About 50 quick sessions. They're about 10-minute. So that'll be fun. That's coming pretty soon. So we want to thank Deepthi. Deepthi speaks all over the world. It's not easy to get her calendar, but she was kind enough to open the year for us. So I am going to stop sharing and hand it over to Deepthi. So um, all of you do not have permission to unmute or turn on your camera, just to respect the speaker. So if you have a question during the session, please put in the chat. You should be able to type in the chat. I will be monitoring the questions. I think Deepthi will take the questions at the end or in between. If Deepthi wants to, I'll read those to her. And at the end, Deepthi probably will hang out for a few more minutes. So if you have any question, follow up, comments, we can all go there and spend some time. But we'll try to finish this by the hour so you can go back to your work or meeting or whatever you have to do. Deepthi, take it over.
Thank you so much, Tayob. Let me share my screen. Are you able to see the presentation in the presentation
Yes,
mode?
yes, I can.
Awesome. First of all, thank you so much, Tayob and Parish, for giving me this wonderful opportunity. It's an honor to speak for the DBA virtual group. So, hello everyone. Myself, I am Deepthi Goguri. I'm a database administrator myself. And today I would like to present on the topic Query Store on-prem and in Azure. So if you are not familiar with the Query Store feature, or if you already know about Query Store and you are here to know more, this session is right for you. There are a lot of demos, like more than half of the session will be demos. So yeah, let's get started. A little bit about me. I'm a database administrator, having several years of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. And also, I did my master's in computer technology at Eastern Illinois University here in Chicago. And I'm an organizer for a couple of user groups. One of them is Diversity, Equity, and Inclusion user group, and also Microsoft Data and AI South Florida user group. And I do volunteer for Women in Technology user group as well. Apart from my work, I love doing arts and crafts. It gives me so much peace in my life. And if you'd like to contact me later, at DBA Nuggets is my Twitter handle, and you can contact me on LinkedIn as well. And I do have a blog where I usually blog about SQL Server. I'm doing currently on Query Store. So if you'd like to know more about it, please visit my website, dbanuggets.com. So what are we going to discuss in this session today? We are going to see the introduction of Query Store, what it is, and later what are the benefits of Query Store. And one of the benefits is plan forcing. So you can go ahead and manually force and unforce the plan based upon which query plan you think is optimal. And once you force the plan, there might be a couple of reasons why it might cause failures, and why, even though if you force a plan, it might go ahead and generate a new plan. And you might be thinking like, hey, I already forced a plan, so why am I seeing a new plan? Because there might be a couple of failures, and you need to know what caused the failures and how to view them. So we are going to see that as well. And we are also going to talk about automatic plan correction, which is especially enabled in SQL Server 2017 and above for enterprise editions only. And also we are going to talk about query store hints, set hints for the query store, which is in preview mode currently. We are all going to see it one by one in our demo. So first, let's talk about the introduction and all the slides. Let's complete them as quickly as possible and then go to the demo section. So what is Query Store? Query Store is the feature that got introduced in SQL Server 2016. So basically, it is a database level feature that you need to go ahead and enable it on the databases, on each and every database that you wanted to enable. So once you enable the Query Store on the database, what it does is it will go ahead and continuously capture your queries along with its execution plans over time. So once you enable it, it will capture the query ID, query text, how much resources are being used for your executions along with their execution plans. So why it is useful, right? Once you capture all of those information, if there is if your queries are generating many execution plans, and if there is a regression, and if you're having parameter sensitive queries, for example, you can easily go ahead and see why the queries get generating more execution plans and why the newly generated plan is not so optimal, and your previous execution plan might be optimal. Now, because you enable the query store option, you can go ahead and manually force the plan that you think is optimal. You can go ahead and choose a plan for your queries so that the next time it runs, it will go ahead and use the forced plan, no matter which parameter you use, which is cool. It, it will solve the problem very quickly. It will give some time for you to fix the query itself, talking to the developers, working with the developers. It might take some time, but this, by using the query store feature, it will very quickly fix the problem until you resolve the problem permanently by changing the code. So it is a database level option only, and it is disabled by default if you are using on-prem SQL Server, and it is also disabled by default on Azure Synapse Analytical Database. And if you are using Azure SQL Database, it is enabled by default. And also, you cannot enable this option on the master database and TempDB databases, those system databases. This is the interesting part, how Query Store actually works. This diagram seems to be complicated, but let me explain in a simple words. Whenever a query is submitted to the SQL Server, it will first go ahead and check if it is running for the first time. If the query is running for the first time, it will go through the compilation and the optimization phases. If it is not running for the first time, then there might be the execution plan already there in the plan cache. So it will go ahead and check if there is a plan already in the plan cache. If there is no plan in the plan cache, and if for some reason you have refreshed or there is a memory pressure and execution plans have been evicted out of the cache, it will go ahead and do the compilation and the optimization in the normal way. But if there is a plan in the cache, then all right, it will go ahead and take that plan from the plan cache. But before moving forward, it will go ahead and check for the recompilation, no matter if the execution plan is newly created or if it grabbed from the plan cache. It will go through this process. So what will happen in this process, right? It will go ahead and check the plan that has been taken from the plan cache or the newly generated plan. Is it same as the forced plan, right? If it is not the same as a forced plan, and let's say like this particular query, we already forced a plan, it will go ahead and check whether it is similar to the forced plan. If it is not similar, then it will go ahead and apply the forced plan. If it is already same as the forced plan, then it will go ahead and proceed. So before the query itself going into the execution phase, it will first capture the query text and the query plan in the plan store. Now, where is this plan store? Plan store is located in the memory. So even before execution, the query text and the query plan will be pushed to the plan store, which is in the memory asynchronously. And then the query goes to the execution phase. After query executes, the runtime stats will be pushed to the runtime stat store, which is also in the memory asynchronously. And uh, once the interval time has been reached, the collected information in the memory will be asynchronously pushed to the query store schema, which is on disk. And all the information, right? Once you enable the query store, all the query store information will be saved in the primary data file in the system views. So what is the difference between the plan cache and the query store, right? Even the plan cache will save all the execution plans. But what is the major differences between both of them? Let's see the difference. When you have the plan cache, the plans will be evicted on every SQL Server restart. But with the query store, all the execution plans and along with the resource consumption information will be retained based upon the cleanup policy. So the default cleanup policy is for 30 days, meaning all the data that has been captured will be kept for 30 days. And once the 30 days has reached, it will go ahead and delete the old data. When you use the plan cache, it stores the latest plans. But query store, it collects the execution plan and all the information, query text, query ID, and resource consumption information over time. Like we discussed, plan cache, like plans can be evicted whenever there is a memory pressure, right? The oldest, least recent use execution plans can be evicted. But with query store, again, until the flush out intervals has reached, the query text information and the execution plan information that has been stored in the memory, like we seen in the previous slide, all the information, the aggregated information that has been captured in the memory will be flushed out to disk once the flush out intervals has been reached. And with the plan cache, it is very difficult to know why the plan has changed because we do not have all the information. But with the query store, as everything is captured, right, regarding the database and the queries running on that particular database, it is very easy to know the troubleshooting, uh, to troubleshoot as well as to identify what are the most resource consuming queries, and it is easy to work on them. So what type of data is collected by using query store? Like I said, query ID, query text, duration like logical reads, writes, physical reads, CLR time, DOP, row count, all the things that you are seeing on the screen, everything will be captured. And before 2017, SQL Server 2017, the wait stats information was not included. But from SQL Server 2017, it's been included as well. And like if you enable the query store, one of the other benefits is like your developers might come to the cube and ask you, hey, can I work on the performance tuning? Can I work on fixing a couple of the resource consuming queries? Can I grab the top resource consuming lists? Because it captures everything, the query store, you can easily go ahead and with simple few clicks, you can go ahead and grab the top resource consuming queries very quickly. What are the operation modes we have for the query store? Once you go ahead and right click on the database, go to the properties. On the left side pane, the last option you have is query store. Once you go there, you see the three different kinds of operation modes. Off, meaning it's turned off. Query store is not turned on. Read only. So once you enable read only, and maybe you have turned it on read write and then you force couple of execution plans, you have couple of force plan and you turn back to read only. So once you turn back to read only, all it does is it will go ahead and read the force plan information, but it cannot write any information into the query store. That's read only. Once you turn it on to read write, It will go ahead and read the force plan information. At the same time, it will capture all of the resource consumption information and wait stats information and write it to the query store. There are also certain capture modes. So capture modes is like what kind of queries will get captured in my query store. We have 4 options, all meaning it will capture every single query, even the insignificant queries that you don't even bother about, like they run just fine, and you do not want to capture those kind of information. You do not want to fill up your query store so quick. All option is not suggestible by Microsoft. Auto is the suggestible option by Microsoft because Auto has an inbuilt algorithm where it will only capture certain queries that we are looking for based upon the uh, based upon the compile time and how many times the query is being executed, compile CPU time. Based upon that, we do not know what it is, like it's inbuilt algorithm, right? Done by Microsoft. So you will be capturing like query store will be capturing those kind of queries that we are looking for, that we need to um, work on, right? And none will not capture anything custom. You can go ahead and customize the policy, like what kind of queries you can capture. So auto is a recommended mode. Let's talk about a couple of options that we have, but later in our demo, let's go ahead and see all of them. Cleanup policy, like I said again, it will go ahead and capture for 30 days by default all the information. And once it reaches 30 days, we'll go ahead and delete the information, the oldest data. Data flush intervals is 15 minutes by default. Once it collects the information in memory, it will go ahead and flush to disk after that 15 minutes. And sometimes it might not reach that 15 minutes, because if you have so much of workload and you are being running the queries and it have to push the data, it can happen. And if you have memory pressure during that situation also, the query store can flush the data that has been captured in the memory to disk. Maximum storage size in MB is 100 MB by default for SQL Server 2016 and 2017. For 2019, it's by default 1 gigabyte. And again, for the complete list of options, please follow the link down below. Do we have any questions, Tayob, until now?
Yeah, so AK, I don't know the full name, asked the question. So the same plan is stored twice. Um, I don't know. I think the answer is the counter get increased. Every time it get used, not the plan itself. I don't know if that's what the question is referring to.
Me too. I did not understand the question properly.
Yeah, the question only said so, comma, the same plan is stored twice, which I doubt, that's probably not the case. I think it's just increase the counter, right? For the same plan, unless it's a
Uh,
different plan, then it gets saved
I
again.
I I believe because we have a plan cache as well as a plan store in the query store. So
Oh, okay.
I believe it saves twice. I have this question. I searched everywhere to get an answer, but I did not find it. I Many people asked me that previously, but as we have an additional store in the query store, right?
Okay, I see the
That's
question
my
now.
question
Okay.
as well. Yeah, that's my question as well. I'll do the research. Maybe I'll contact Microsoft on it, and once I get the information, I'll get back to you on that.
Sure. Uh, then the next one is from Ravi. Enabling query store consumes memory from server. If yes, does that impact performance of other processes?
So it is completely based upon the settings, I believe. Um, there are like best practices of how to enable the query store. If you can go ahead, and I provided that link down below. It's pointing to Microsoft Docs. We need to know each and every option, what each of them means to go ahead and enable on them.
Okay. Next one, folks. If you have a follow-up questions, please put it there. We can come back and review those. What happens if we need more space for both SQL 2016 and 2019? Can we change the storage size for this?
Yes, you can change the storage size for the query store. It don't have to be on default.
Correct. And if I understand correctly, this is per database, so it's going to increase your database size. I mean overall size. All
Right,
right. So
right.
next one is cleanup policy. Cleanup policy. If it is set to 30 days, when will it clear the old plans and oh no cleanup policy? If it is set to 30 days, then will it clear the old plans and active plans too? The plan will be reused. You don't generate new plan unless the query changes.
It won't clean up the forced plans for sure.
Okay. Um, okay, that's it for now. Yep,
Okay, okay, thank you. I'll go ahead then. So let's
sure.
see the query store benefits. Um, so one of the query store benefits is you can go ahead and compare the regression between the execution plans if you have a parameter sensitive queries, or if you have queries that keeps on changing the execution plans and you think that one of the execution plan will be working optimal, because there is a way in the query store that you can go ahead and compare two different execution plans side by side together and compare the resource consumption, and you can go ahead and manually force the plan, and it can fix, like it will quickly fix the plan. Like you can shift from the non-optimal plan to the optimal plan, um, and you can quickly fix the uh, problem without changing the underlying code. Again, this is a temporary fix, because permanently you need to know why the query, it is creating so many execution plans, and you might have to work with the developers, talk to the application team to figure that out. But until you fix, because in some cases you'll not be able to do it, or do it immediately, change the code and everything. In that case, query store will be really helpful. And personally, I used query store um, for, while doing the database upgrades. I'll show you how I did in my demo. So basically, like we discussed, there are three stores in the query store: plan store, which will actually capture the execution plan information, query text, query ID, runtime stores. Runtime stat store will store the runtime stats information, and of course, wait stat store will store in the categories the wait stats information. There are certain catalog views that you can use for the query store, like query text, context settings, and runtime stats store. Like you can grab the runtime stats information by using these catalog views. And there are certain store procedures where you can go ahead and force and unforce the plan by using these store procedures. So the advantage is, like, while you use these T-SQL code, it might also capture from in your monitoring tools, but it might not capture by using the graphical user interface if you force and unforce the plans over there. And there are also other store procedures here, like query store set hint store procedure that we are going to talk in our demo as well. Let's talk about the plan forcing. Plan forcing is similar like use plan query hint. Like one of the benefits we discussed, that we can force the plan. So you can force the plan by using the graphical interface or by using it by the store procedures here. And I do suggest using the store procedure to force and unforce the plan. SP query store force plan will force it, and SP query store unforce plan will unforce the plan. Once you force the execution plan, once you have the force plan on your query, that doesn't mean that it will not create any more execution plans, any new execution plans. We have chances of creating the new execution plans, and we need to know why it just ignored the force plan and why it generated a new execution plan, because there might be certain failures. So you can monitor those failures by using the graphical user interface, as well as you can use the system catalog views to get those information. But again, it will only show you what is the number, what is the number of the failure, and what is the latest reason for the failure. It will not show you the history of the failure information. To capture that information, you can use the extended events. And I have explained in one of my uh, blog posts how to capture that information by using the extended events. So, like the objects, when can we see these failures? Like, right? The objects that are being used in the execution plan, in the forced execution plan, if they are being dropped, like for example the indexes that you are using, if they are altered, if they are dropped, that will force the optimizer to go ahead and create a new execution plan. We are going to see that in our demo. So you can monitor those failures by using the graphical user interface, by using queries with forced plans. And you can also do that by using the catalog views and the query that shows here. You can get that more information by using the Microsoft Docs down below. Automatic plan correction is especially enabled in SQL Server 2017 and plus, only for the enterprise edition. So what does the automatic plan correction do? By enabling the automatic plan correction, the query store will automatically go ahead and monitor the regression between the execution plans, and it will continuously monitor whether the newly generated plan is optimal than the older plan. If it thinks the newly generated plan is optimal and working fine than previous one, it will go ahead and automatically force that plan for us. We do not have to go ahead and monitor continuously. That will automatically happen, so that you know once we force the plan, and if we depend upon us, like we need to go ahead and monitor whether the force plan is still optimal or whether the new plan will be optimal, unforcing the plan and forcing the new plan, it's very tedious task, because as a DBA we have several other tasks to do, right? And many times we forget things what we even forced. So taking the advantage of automatic plan correction will take some of the burden from us, where it will automatically go ahead and force the plan that is optimal. And once it forces the plan, it doesn't stop there. It will go ahead and continuously monitor for any newly plans getting generated, and whether there is regression caused in between those plans. And if there is no regression, like if the newly plan generated is working worse than the previous one is working just absolutely fine, then it will go ahead and just ignore and continuously monitor. So you have to enable that option, automatic plan correction, on the database by using alter database name, set automatic tuning, force last good plan to be turned on. And also you can find the reasons of why it actually decided to unforce and force a new plan. You can find those reasons by using this DMV, sysdmdb tuning recommendations. And you can also, the automatic plan correction is automatically enabled on Azure SQL database. If you wanted to disable it, you can go ahead and disable. But you can find that under the database in automatic tuning option, left side your screen. Once you open up, it will open up a blade where you can go ahead and see to if you wanted to use it, which is by default it's turned on, or if you wanted to disable it. So query store hints option is one more feature which is in the preview mode. So let's take an example and explain this. Let's say you have a parameter sensitive query. Most of your queries are running fine with one execution plan, but you have that parameters sensitive parameter where it go ahead and generate a new execution plan. You can use the hints that we generally use for the within our stored procedures, like the hints that we use, like recompile options that we choose. But here, the change is like you don't have to touch the stored procedure at all. That's the beauty of the query store hints. So especially for the query store, you can go ahead and recompile a store procedure even without entering the recompile option within the code of the store procedure. So that the next time the store procedure runs, it will go ahead and sniff the parameters that are sensitive, and it will go ahead and generate a new execution plan based upon those parameters. You do not have to touch the code. So how do we do that? By using SP query store set hints. All we need to get is the query ID. So what is the query ID for my store procedure? Get that query ID and then insert the value, the query store hint value you want, which is here. For example, we are using recompile. The next time the store procedure run again, it will go ahead and sniff the parameter and change the execution plan accordingly. It will go ahead and recompile. And not only the recompile, you can also use the other query store hints option like max, stop, recompile, maximum, minimum, memory grant size, compatibility level, such kind of hints. So let's go ahead and see the demo. Tayom, are you able to see my management studio?
Yes, I am.
Thank you. So we are using Adventure Works database and other database as well, worldwide importers database as well. And we are using on-prem as well as Azure. So let's go ahead and turn it on. Turn on the query store feature on the database, alter database, set query store to be turned on. And I'm using the operation mode as read write. I turned it on. And I'm altering the database and setting the query store options here. Do not do this as is in production because this is just my demo. I have done it, by setting couple of options here, but you need to go ahead and uh, read the best practices and what each option means for your workload, and then enable and change those defaults. So here, operation mode is read write, which we discussed, and the cleanup policy will, once it reached the 30 days, it will go ahead and clean up the old data. And data flush interval in seconds is 3000, which is 15 minutes by default. And as I told you, it will collect the data, and then it will collect the data in the memory and then flush out to the disk. That's the seconds here. And maximum storage size is 500 MB here, which I placed as a default, but you can go ahead and change that. So the important one, which we did not discuss, is interval length in minutes. Here it is 15 minutes. So basically, so each 15 minutes, you get a new interval. Let's say we started the interval number 1. In that particular interval, no matter how many times the store procedure runs, it will only have one row inserted into that particular query store in that particular interval. Once you hit the next interval, again, no matter how many times that query store runs, again it will insert only one record into it, and all the other resource consumption information will be aggregated and will be presented. Size-based cleanup mode is auto, which is by default, it's auto, and please do not turn it off, because once you turn it off, your query store will blow up. And um, if you put the size-based cleanup mode as auto, what happens is once the size has been reached 90%, it will go ahead and automatically clean up the query store old data until it reaches 80%. If you turn it off, it will go ahead and completely fill up the size, and your query store will automatically go into the read-only mode. And by placing it is in the auto mode, you're not you're not taking that into read-only mode. And maximum plans per query, I put it too much high, but you can change it. You can change that, like how many plans you wanted to put per query. And wait stats capture mode, I turned it on. Let me go ahead and do that. And here I wanted to check what are my query store options that I enable by using the sys database query store options. If you check the results, you can see all the options that I have chosen, like maximum size, interval length in minutes, size blades, cleanup mode is auto, all the information that I have chosen. Let me go ahead and clear up my query store just in case and then free up my prop cache. Let me run a couple of store procedures here just to show you how the query store capture the information and how it shows the execution plans in it. I executed that and this is my database. So once you enable the query store, you have the query store folder created. Expand that and go to the top resource consuming queries. View top resource consuming queries. This is the graphical view. So to see what query it executed, you can hover your mouse and see. And if you see the query, right, it is parameterized. You cannot see which parameters you used actually, but you can see the query. So I wanted to see the query itself by using the tabular mode here. You can click on it in the grid view mode, which will give you the query itself. So here we executed two store procedures. So you get the query object ID, object name, query text in the parameterized view, and the plans that got generated. You can see it here. So we have captured that information, right? Now, what if I go ahead and see whether these plans are there in the plan cache as well? These plans are there in the plan cache. So what if I go ahead and delete the plan cache? Will that also delete the query store? And this was one of the questions that the previous attendees asked, so I put that in the presentation. So I'm cleaning the procedure cache and I'm checking my query store. It's still there. The data will be persisted even if your plans are evicted out of the plan cache. Let me clear out my query store. And then now I wanted to run some ad hoc queries. How do the ad hoc queries work with the query store? How do they get captured? So I'm running the same exact query with a different parameter, and I'm running it twice. So let me execute that. Go to the query store, refresh by using the refresh button over here. If you observe the same exact query, just that we change the parameter value, right? As it is ad hoc, each execution will create a new query ID. These two are the same exact queries with a different parameter. So just imagine if you have more and more queries, ad hoc queries running on your um, running in your query, running in your on your database where you enable the query store, it can easily blow up your query store size, right? So because even if a slightest change like a space, I added the space for the same exact query and I'm running it again with the same exact parameter, what will happen? If I execute that, go to the query store, refresh, and if you observe here, the same exact query with a simple slightest change space, right? I just added a space, it created a new query ID. So it is suggestible to go ahead and parameterize those, create a store procedure by placing the same exact query within a store procedure and create a store procedure so that it can go ahead and use the same query ID. I'm creating a store procedure, placing the same exact query, and creating the product ID here. Now I'll go ahead and clear out my query store and procedure cache. And then I'm executing the store procedures that we created. with the two different parameters. Let's see how they get captured. Refresh the query store. Now, if you see here, we executed it twice, but as it is a store procedure, it have only one query ID, right? And then two different execution plans. Because they are parameter sensitive, these two are parameter sensitive, it went ahead and created two different execution plans. Now, if you go ahead and hover your mouse onto those execution plans that got created, and if you see the total duration, it's 1152 milliseconds. And for the plan ID 1, I see it 5.2. Let's say I would like to go ahead and force this plan. You can go ahead and compare these plans by going ahead and highlighting these, and then you can go ahead and compare them here. Compare the plans for the selected query in a separate window, and you can go ahead and compare these plans. The plan ID 1 have index seek and the key lookup, and the second plan got clustered index scan. Now let me go ahead and force the plan number 1. Let me close this. Plan 1, go ahead and choose the plan 1 and then go ahead and press on force plan. Do you want to force the plan 1 for the query 1? Yes, I do. If I click on that in your demo, just do it by using the transact SQL to force the plan. But to show you how it works, let me do that. So once you force the plan, you'll get a little tick mark over here representing that that plan is currently being forced. So the next time you go ahead and execute any with any parameter, the store procedure, when you execute it, it will go ahead and use the same execution plan. Let me go ahead and turn on the actual execution plan on to show you. If you see here, it is using index seek and a key lookup. It is using the forced plan. And if you refresh here, we do not have any more execution plans being created. It is using the same plan ID number 1. That's how the force plan work. You can go ahead and put the operation mode as a read only. Now I'm doing that. And I'm going ahead and just clearing out the procedure cache. As we turn on the read only mode, right? And then I cleared out my procedure cache. So the next time I run the store procedure, as it is read only, it doesn't place any information in there, but it will go ahead and read the information. And then it uses the same execution plan, the forced execution plan, index seek and a key lookup. But it cannot write the information. So to turn off the query store, alter the database name, set query store to be turned off. Will turn off the query store. Now let me go ahead and close it out, open my next demo. How did I use the query store for my capturing the baselines? So we have a database in 2012 mode. We moved that to 2016. So we wanted to capture the baselines, like how it used to run previously. Because once we upgrade the database, mostly it runs absolutely fine, but there might be a couple of queries that might not work properly, that might take long time. So what if I migrate the database, but then place the database in the same old compatibility mode and then turn on the query store on that database with the older compatibility mode, like it used to be in the older system, and then run all the queries on the newer system with the old compatibility mode on, with the query store on, and then capture all of the queries and then go ahead and upgrade the compatibility mode of the database and then run your queries to easily go ahead and see the regressions that might cause later for a couple of the queries. So let's say the database that I migrated is a worldwide importers database, right? Let me go ahead and clean up my cache. And here this is a database that I have been migrated. So let me first enable the query store, right? Let me enable. I migrated it to 2016 mode, but then I will change back to the older compatibility mode, which is 2012. And then let's say we have a store procedure, but just I'm making sure it has been created. Now we are capturing the baseline. We are capturing all of the queries. Before doing that, I will just clear out my procedure cache and then clear out my query store. Now I'm capturing the information just like the way it used to work on the older compatibility mode. Okay, now I did that. Now, if you go ahead and see the database that we enabled, right? This is the query store for this database, top resource consuming queries. And then go ahead and see in the grid view mode. This is the plan ID that got generated. Now I'll go ahead and change back, upgrade the database compatibility mode to 2016, and then run the query again. It might run fine, it might not run fine than before. Now, if I refresh that, if you see the newly generated, if you see the latestly like the newly generated plan ID will always be the bigger number, the plan ID 3. So the plan ID 3 seem to be working fine, better than previous one, right? It might go either way, right? Most of the queries will run fine. Here my query is running fine. But then the main point that I wanted to bring this up is you can know what it used to run previously. It used to run in 5.62 milliseconds. Now my query is running fine and it is running based upon how duration it is running in 1.86 milliseconds. You know, you have that ability. Like if it goes the other way, if it is not running fine, if it is taking more time, you have that ability to go ahead and force the plan which used to run fine. So that is the benefit. And in my while I was doing these database upgrades, there were situations, couple of situations where I went ahead and forced the last good plan from the older compatibility mode. That's how I used it. Now let me go ahead and show you the failures. Once you force the plan, right, doesn't mean that it will not generate the new plans. It can
Deepthi, we have
generate the
10
new.
minutes,
Sure,
10 minutes to go.
sure, thank you. So let me go ahead and we are going to use the same database here. Let me go ahead and clear out query store and data and then procedure cache. And here, if you observe, here so let me execute this particular store procedure. Um, this is a store procedure, and let me go ahead and that is a store procedure. So uh, I'm creating the suggestible index on it. So I'm creating the index on this particular store procedure, the supporting index. And that supporting index will be used right now if you execute it and refresh the plan ID 4. If you see here, it is using the index C, the index that I have created, it is being used. So what I'll do is I'll go ahead and just drop the index that I have. But before dropping the index, I have to force this plan to see the failures. So I'm forcing the plan number 4. Now it is being forced. Now I'll go ahead and drop that index. So we have forced a plan and I have dropped the index. Now I'm executing the plan, the store procedure again. Executed. Now I refresh, right? It will cause the failure. It might be using the same plan ID 1 for this particular execution. That's why it did not created any. Now, if you wanted to go ahead and see the failure for this particular execution, right? You can see queries with the force plan, right click, view queries with the force plan. If you see here, the query ID 3 is using force plan ID 4, and there is a force plan failure count, which is 1. And the reason for that is no index. So there is no index within that force plan, and that is the reason it went ahead and used a different plan. You can go ahead and create the execution plan again, create the index again that you have been dropped, the same exact index. If you execute it and then go ahead and run the store procedure again, there is no problem for it to go ahead and use the same force plan. So it will be using the same force plan. If I go ahead and enable the actual execution plan, execute, and see the execution plan, it is using index seek. So it do not have any problem to go ahead and use it once you recreate the index. Now, what if I go ahead and drop and alter the index by adding a column in it? I'm modifying the index. Now running the same store procedure again and seeing the execution plan, it is using a different execution plan. If you see here, it is using column store index. Now to know the reason why, refresh and see the reason. Forced plan failure count is 2. And again, you cannot see the history of the failures. Now it says there is no plan associated with that particular, with there is a force plan, but now I completely changed the schema. So it gave me there is no plan associated with that index. And then it gave the failure. But if you observe here, there is a failure within the query store and it captured the information, but it did not fail the query itself, right? And let me go ahead and show you the automatic plan forcing very quick within 5 minutes. So I'm connecting to my Azure SQL database. So here I'm using AdventureWorks again. Let me go ahead and turn that on, turn the automatic plan correction turn on. I put the database in the serverless option where it will go ahead and pause the database when it is not in use. So the first couple of execution, it fails, but then it will succeed eventually. And if we did not cover up the session completely, if we are unable to cover up this demo, I already have all the demos. Like I have another presentation that I have given along with all of these demos. You can also go ahead and see in that. Okay, Tayo, this is taking time to go ahead and warm up and execute. Okay, it executed. So we have 4 minutes. Let's do that within this 4 minutes. So what I'm doing is I am using the same store procedure that we have been using. So I'm creating that store procedure. And this is AdventureWorks database, which is in Azure SQL database. I'm clearing up my query store data. Now again, I have to run in the database. Okay, now I'm not forcing any plans, but I'm making sure that it automatically force a plan. So I have to first create the workload for it to go ahead and compare. So let me go ahead and execute this particular workload for 50 times. Execute. Come on, run quick. I do not have time. So it created. So let's go ahead and see in the AdventureWorks database, query store, top resource consuming queries, right? If you see here, it generated plan ID 1. Now, let me go ahead and, where is it? Okay, let me go ahead and clear out my procedure cache and then create the regression. This is a parameter sensitive query, a parameter sensitive 707 is parameter sensitive. So let me go ahead and execute that for 10 times to create the regression. Now, if you observe, if you refresh, it already forced a plan. No, this is a different, this is a different. So let me go ahead and open this up again. If you see here, it created a new plan, right? Okay, now what I'll do is I'll go ahead and this one, I'll go ahead and run the previous workload again so that it can have the ability to go ahead and compare and then force. So I'm running the same execute same parameter 942 30 times again, and then go ahead and see here, right? Refresh, refresh. Did you observe it automatically went ahead and forced the plan ID 1? That's the beauty of the automatic plan correction. It will go ahead and continuously monitor and it will, and based upon resource consumption, it will go ahead and automatically force the plan for us. And it is especially enabled in enterprise edition of SQL Server. Let me go ahead and um, share my slides. So once you enable the query store, you would like to get that information from the catalog views. So in the on GitHub, we have QDS toolbox, which have been created by Channel Advisor. They have they have needed queries that you can go ahead and use once you enable your query store. It's completely free. Go ahead and use it. To learn more, the best practices information you need to definitely look into before enabling it. And I also created query store um, blog post on the same topic. You can go ahead and look into. And these are the resources, Microsoft Docs, that I have followed to prepare this presentation. And the pictures that I used are from pixels.com, which are completely free to use. And I would like to thank you, Tayob and Paresh, for giving me this wonderful opportunity. I hope I completed in the given time frame.
Yeah, so thank you so much, Deepthi. So I'm gonna, folks, if you want to hang out, you can. Deepthi, if you have time, I want to read a couple of questions, probably comments also.
Mhm.
Then we'll close it. So we're talking about memory usage when using query store and the impact. So Senthil put a comment that yes, it affected my database server if we increase the
Mm.
memory to query store. The next one is why does the query store saves the info in the same database file? I think we talked about it, and you said you still trying to find out the exact location, right? But there is a different query store and there is a planned cache, right? So
Oh, the memory in the memory.
no, I think this is a separate question. It says, why does the query store saves the info in the same database
Oh,
file?
yeah, it saves in the same database file and it saves definitely in the primary data file, and you cannot change that.
Okay, great. Can we find parameters parsed to any store proc in the store? I think you already answered it that it's a no.
Yeah,
So
no, it doesn't store, but then you can capture that information in extended events.
correct. Um, okay, we'll update. Will update database statistics affect the query store?
Uh, Very good question. So update statistics and uh, there are a couple of reasons like update statistics or like rebuilding indexes. They might cause the queries to generate the new execution plans, and new execution plans might generate and store in the query store, but that doesn't directly affect the query store itself. It doesn't.
Okay, thanks. Uh, in what scenarios the query store will have multiple plans? If the query is pinned, the plan is not affected even after the index rebuild or stats update. I think you have shown some of this,
Yeah,
but I'll let you answer if you want to add anything.
there are reasons that like the same reasons, right? The statistics update and the um, index rebuilds can cause the new plans to be generated.
Okay, I think we answered that. Chris helped me also. I put some link from Bob Ward, sorry. In an AG, can you enable store for readable secondaries, which is coming in 2022?
Mhm.
So folks answered that already. Senthil said, nice, that will be huge help. Will the cleanup job cause any issues to the database server?
Can the cleanup job? I don't think so.
Okay.
I'm not
Paresh has a
100% sure, but I'm thinking it. I don't think so. I heard somewhere that while the cleanup process is happening, whether the query store will continuously capture the information or not, but I'm not 100% sure about that.
okay. Um, so Senthil, you can follow up with Deepthi directly,
Yeah, yeah,
and maybe she can get back
definitely.
to you.
I'll look into it and we'll let you know.
Um, a lot of people says, okay, Paresh has a question. Do you know if under any circumstances a column store index will be recommended?
Uh, that is direct, not question related to query store, Paresh. We'll talk that later. Uh, because I'm not sure about the answer.
And then bunch of people commented, it's wonderful, thank you, awesome and interesting. Question, I have more than 800 in parentheses 1 to 2 GB size databases on Prem host. Do you suggest enabling QS on each DB?
Yeah, if you want to capture you can go ahead and do that. But make sure you are sizing up based upon your workload, the size of the query store, and then the settings that I talked about, right? Please read uh, the best practices before enabling it and changing the defaults, because defaults, you do not have to keep the defaults definitely, right? You can change that, but I do suggest it. You can turn it on.
And the last question from Manish is there any other overhead to the server? So any other overhead is a generic question. Probably Manish is referring to what we already discussed so far. Maybe that's what I'm assuming.
Mhm.
So that's the
Again,
last.
based upon settings, how you are settings, like if you put the option, like why I'm stressing that out is like the cleanup policy. If you turn it, like auto is the option, but if you turn it off, then it will blow up the query store. It will not clean up automatically, right? So that is the reason why I'm forcing it out. But it query store has been helpful for many people. It has helped me. I definitely tell you to try it out.
Okay, awesome. Chris put some links for other folks to look at. Chris would and help. Thank you for those help. Um, Hold on. Okay, Senthil has ad hoc queries are a bigger issue with QS as it feels the queues faster. Yeah, Deepthi already mentioned that to move
And
those to
also
stored
the
procedure.
other point is there is this Microsoft Docs has a query on their website, on their docs, right? Microsoft Docs, where you can just go ahead and flush out all the um, ad hoc queries only without touching any other queries. There is a query for that.
Awesome. Okay, so we will post the recording. I have to probably do some cleanup. I have to see, how to clean up the recording before and after. We'll also bring the slides and the demo code in the URL that I posted before. Probably by this weekend, we'll have everything in place. Ray is asking, have the link for the last one. So Deepthi, if you have it handy, you can put in the chat,
Oh
the
yes,
one you
yes,
just
it's
mentioned. If
yeah.
you don't have it, maybe later on. If Okay, Deepthi will put in the
You
chat,
mean
Ray,
the
for you.
cleaning up the ad hoc?
That's what I believe that Ray is
Yeah,
referring
yeah.
to. Yeah, yeah,
I'm doing it right away.
yes, that's what Ray is saying. Yeah, that's what he's looking for. Yeah. Um, Oh, Senthil already put the whole query
Okay,
in the
okay, good.
chats. Okay, so thanks,
Okay.
folks, for help. This is nice that everyone is helping out. It's not just the speaker. Awesome. Yeah,
Yeah, and I'll be providing the demos as well, and the full session link is because I just missed one of the demo. Let me post that very quick. This is the I can post in the message.
Yeah, post in the chat. Yes, please.
Yeah, the chat. So if you would like to see the demos, the complete demos, I just missed one of them. I'm really sorry. I didn't get the time to cover that up. You can go ahead and look into that video for the complete presentation.